Okay, so today we're going to be working on some inequalities. So we're going to be doing lots of examples. So let's get started with the first one. We have 3 plus 2x is less than 7. The goal here is to get x by itself, so let's subtract by 3 on both sides to get 2x less than 4. And now I want to get x again by itself, so we have to divide by 2 to get x is less than 2. So that is our solution, which looks like this on the number line. So we go to 2, we put an open circle, and we shade to the left. So we're looking at all values that are less than 2. Okay. Next example, we're going to be looking at 5 minus 3x less than 5x plus 2. First thing we should do is take care of the constants, so I can either subtract by 5 or subtract by 2. So in this case, I'm just going to subtract by 2 to both sides. So I'm going to have 5 minus 2 is 3, minus 3x is less than 5x. And then I'm going to move the 3x over to the right-hand side by adding 3x. So when I do that, I'm left with 3 is less than 8x. And so x is greater than 3/8. So here I'm looking for all points that are greater than 3/8. Now we're going to be looking at a compound inequality. So we're going to be looking at negative 7 less than 2x plus 5 less than 9. So the key to doing these problems is to subtract or add, multiply, or divide to all sides of the equation, or the inequality. So for example, here, I'm going to subtract by 5 to all sides of the inequality. So negative 7 minus 5 is going to give me negative 12 less than 2x less than 4. And finally, I wanted to divide by 2. So I'm going to have negative 12 divided by 2, and then x is by itself, and then 4 divided by 2 is 2. So I'm looking at all values of x between negative 6 and 2. Here, a common trap for students is to take the negative 12 less than 2x, and they would flip the inequality to become negative 6 greater than x. This is wrong. We only change the inequality when we're dividing or multiplying by a negative. Here we're dividing by 2. 2 is positive, so we don't change the sign. We leave it alone. Okay. Let's look at another compound inequality. We have 3 is less than or equal to 4x minus 1 less than 5. Whatever I do to one side of the inequality, I'm going to do it to the other. So let's add 1 to all sides to get 4 is less than or equal to 4x less than 6. I'm going to divide by 4, so I'm going to have 1 is less than or equal to x less than 3 over 2. Because here, this is equal to 6 over 4. Okay, moving on. 4 is less than negative 2x plus 5 is less than or equal to 7. I'm going to subtract by 5 to all sides to get negative 1 is less than negative 2x is less than or equal to 2. Now, I'm going to be dividing by negative 2 to both sides. So this means I'm going to have to switch the inequality. So negative 1 divided by negative 2 will give me 1/2. And instead of less than, we're going to change it to greater than x. And then instead of less than or equal to, will be greater than or equal to. And then 2 divided by negative 2 is negative 1. So x is between negative 1 and 1/2. Let's see, 5 is less than or equal to 1/3 x plus 1 is less than or equal to 6. I'm going to subtract by 1 to get 4 less than or equal to 1/3 x less than or equal to 5. Because I have 1/3, I'm going to multiply by 3 to get 12 is less than or equal to x less than or equal to 15. So x is between 12 and 15. Next, we have 2 over x is less than 3. Now there's more than one way to solve this type of problem. We can take it case by case and say, well, let's look at when x is greater than or equal to 0, and let's look at when x is less than 0. This is totally fine, except it's a little more complicated. So what I would advise to do is to bring the 3 over to the left side, and then get a common denominator. So I'm going to multiply 3 by x over x to get a common denominator of x. And then I'm going to get 2 over x minus 3x over x less than 0. So I can combine it under one fraction to get 2 minus 3x over x is less than 0. And now I'm going to draw a number line. I'm going to look at when the top is equal to 0. So when is 2 minus 3x equal to 0? Well, that's when 2 is equal to 3x, and that's when x is equal to 2/3. I'm going to label my graph here at 2/3. And then finally, I'm going to be looking at when the denominator is 0. Here, the denominator is just x, so we're going to set that equal to 0. And I'm going to put an x here to denote that we don't want to include 0 in our answer, because we can never divide by 0. Now let's pick values between 0 and 2/3. So let's do outside first. Let's do left of 0. We can pick -1. So if I plug in -1 in my inequality, we have 2 minus 3 times -1 over -1. That'll be 2 plus 3 over -1, which is 5 over -1, and that's just -5. So this means this is negative. Next, let's pick another number between 0 and 2/3. We can call it, say, 1/2. Let's plug in 1/2 in for x. So we have 2 minus 3 times 1/2 over 1/2. And that will be 2 minus 3/2 over 1/2. And 2 minus 3/2, we can think of 2 as 4/2. So 4/2 minus 3/2 is 1/2. 1/2 over 1/2 is just 1. So this is going to be positive. And then finally, we can pick a point outside of 2/3. We can just say 1. So let's plug in 1 into our equation. We'll get 2 minus 3 times 1 over 1. We get 2 minus 3 over 1, and that's -1. So that means here it's going to be negative. In this problem, we want to see when this inequality is less than 0. So it's going to be less than 0 to the left of 0 over here, and to the right of 2/3. Because we're looking at strictly, so this is strictly less than 0, we do not want to include 0 and 2/3. And anyways, we can't include 0 because that would mean we would divide by 0. So our answer would be x less than 0 or x greater than 2/3. That's our final answer. Again, the key to this problem was to get it under a fraction. So we started off with 2 over x less than 3. We got a common denominator. We set the top and the bottom equal to 0. And then we drew a number line to decide, okay, when is my fraction less than 0? When is my fraction greater than 0? So that's going to be the common technique for the next few problems.